Hello, everyone. My name is Michael Schachter, and I'm a Senior Product Marketing Manager at Allot. And I'm joined today by Ariel Cohen, who's a Senior Product Manager at Allot.
Hello, everyone.
And just a quick word from our sponsor. Allot, as you may know, is a leading provider of innovative network intelligence and security solutions for carriers and enterprises, leveraging our experience in carrier-grade inline packet inspection capabilities to help make your network smarter and your customers secure. But today we're going to talk about NFV and how we bring those capabilities to bear in a virtualized environment. So Ariel is going to take us on a journey in which he shows the actual implementations of NFV-compliant network intelligence and security solutions that we have already deployed at Tier 1 customers around the world. And the solutions are also relevant for enterprise networks. Before we get started, just some quick logistics. If we take a look at the screen, you'll see that in the middle, of course, is the presentation. In the upper right is a box where you can click if you need to contact us. In the lower right, there are some links for you to download additional resources. And in the upper left, there's a question and answer box, and feel free to insert, and we will try and respond at the end if there is time. And finally, during the course of the webinar, we will have a few poll questions that will appear instead of slides, and it'll be helpful if you can answer them so that we have a clear sense of who's out there and give us some feedback on some of the things that we're talking about. Okay, so let's get started. And just to help us out, so we have a sense of who's out there, if you can fill in this first poll question quickly, letting us know if you're working for a fixed carrier, a mobile carrier, a converged carrier, or some other kind of organization. Please give us a quick answer there, and we'll have an idea of who our audience is. Okay, so we'll move on and take a quick look at the answers in percents. And we've got mostly others, and 12.5% are converged. Okay. And one more quick question. Before we dive into the examples of our NFV deployments, we'd like to get a sense from you of where you think the primary reason or value for implementing NFV comes from. Is it to support the upcoming 5G architecture? Is it all about saving CapEx because you utilize your hardware better? Or is it perhaps mostly about saving OpEx because maintenance and deployment is more agile? Okay, interesting results there. 66% are all about supporting 5G. And I guess this is a multiple choice, so people also selected CapEx at 44% and OpEx at 22%. And of course, you're all right, and we'll hear about some of this as we move forward. So let's get started. When talking about NFV and where it started from, it's clear that what people are looking for and what service providers and also in enterprise environments are looking for a way to be more cost effective, reduce your spending on proprietary hardware, have systems that are easier to deploy and maintain, giving you the ability to innovate and deploy new services more cost effectively. And as we all know, for many years, hardware has been a limiting factor, either because it was expensive and slow to deploy, maintenance costs are significant, and often in environments for telecom, you had to kind of deploy worst case scenarios to make sure that you were always covered, and that was very inefficient, very expensive, because you rarely needed everybody's worst case scenario. And so NFV was really sort of a game-changing concept that it promise to accelerate all of the above, right? Because if everything is standard and the IT is all virtualized, then you can get much better utilization out of your deployed network. And that was the dream and the goal and the hype. And as we're talking about in this session, is it hype or is it reality? And so the answer is it's a little of both, but what we hope we'll take away from today is that it's more and more a reality and will continue to grow. For one thing, if it were only hype, it would be a bubble that would have bursted, right? We're not obviously at the end of the journey yet, but we do see that there are real cases, and we'll share with you a couple of NFV already working, especially in mobile. But there is still, a long way to go in terms of maturing the overall environment, the platforms, the competing standards. So there's work to do, and vendors like ourselves, as well as the standardization groups, and as well as people like yourselves who are the actual consumers at the end of the day, the operators and the data networks, we all need to work together to move this forward, and especially around topics like interoperability and standardization.
Okay, thank you, Michael. My name is Ariel, and I'm a senior product manager at Allot, in charge of all of our NFV-based solutions. I see the attendee list, and I see some of our longtime customers here, so thank you for joining us. And I see also, let's say, new faces, so I'm hoping that you will benefit from this session. We don't have a lot of time, and I really want to eventually review some real-life use cases we are doing on NFV. But before that, I'm presenting a slide that I think if I woke every one of you at 3 in the morning, you would know by heart, the Etsy NFV architecture, which is the basis for all of this. And this is the theory behind the infrastructure. And Michael, please move on to the next slide. And this is a slide describing how Allot is implementing our NFV-based solutions, where we are compliant with both VMware as an NFVI infrastructure or OpenStack. We see customers that have chosen VMware, and we see customers that have chosen OpenStack as an infrastructure. On top of this private-based network, Allot deploys its entire solution. And when I say entire solution, I'm talking about all of our user plane components, which handle traffic, which do DPI, which handle security, and also all of our management components, all of the control plane elements that manage subscribers and policies and reporting, or in short, all of our portfolio. Additionally, on top of this environment, there's usually a MANO level, a management and orchestration level, where depending on the customer, there are different ways to look at orchestration and to approach this. And I'm happy that Allot also has its own orchestrator, our own Etsy-based VNF manager, which in lack of a customer's orchestrators or any integration that was performed, we can offer also our standalone VNF manager, which can perform orchestration of Allot solution on top of the cloud-based network. Okay, great. So what is the rationale for Allot to transition to NFV? I think I'm stating here the obvious. The market is going there. Our customers are going there. The industry, the standards are going there. But as a sense of a journey, Allot usually had proprietary-based solutions where our DPI and security was provided on top of proprietary hardware. Eventually, we transitioned to cost-based hardware. So we have appliances that are provided on standard servers, which already makes us much more efficient and cost-effective, because this is actually doesn't require proprietary hardware. And also, we are providing our solutions as virtual editions, which can be deployed on top of hypervisors, exactly for the use cases where you have your own servers and you want Allot to deploy our solution as virtual machines. and of course a fully fledged NFV-based solution, which is NFV compliant to the infrastructures I presented before, which are VMware and OpenStack. Moving to NFV means actually that as a company, we are providing our customers software and licenses. There's no shipping anymore of any products. There's no repairs. There's no RMA. There are no people on site. This really brings to a huge operational efficiency. We can upgrade and add new services quite easily. And all of this is, of course, still based on a hardware, but the hardware is cost-based, which makes it future-proof because our customers can run different softwares on the same hardware depending on their needs and on their applications. So let's move on. This slide is not designed as a deep dive into our architecture or into our solution, rather to give you a sense of, on the left hand, we have the, let's say, the proprietary-based hardware solution that does DPI, and it is based on a blade server that has all sorts of network elements like flow balancers to get and send traffic from the network, and the DPI components, which are called core controllers. They are marked in yellow. And all of this is based on a blade system, a physical system, that is providing the service of DPI and security to operators' network. What we did in NFV, which is not an easy or simple transition to do, is convert all of this thinking into NFV, and we really built from the bottom up a fully virtualized service gateway for NFV-based networks, where we are not just packaging our software in a virtual template and running it over a hypervisor. We are actually providing a NFV entity that is composed of different virtual machines, which are represented on the right by the yellow boxes, which are marked VFBs, and the orange boxes, which are marked VCCs. These are the flow balancers and the core controllers. And the beauty of this is that it performs the functionality of DPI and security services while being deployed on the cloud on different servers and connecting together and working as one single virtual chassis on NFV. So this is the sense I want to give you, that we have our full solution running on a truly NFV-based platform. Yes.
Okay, we have another quick question for you out there. The carrier network that you work for or are getting services from, do you know, if you know the plans for becoming fully NFV compliant, just to get a sense of, you know, what the timing is out there in the real world?
Yeah, this will be an interesting answer.
Okay, so it's definitely, you know, ramping up. Next year, 25% of you responded that there will be NFV compliancy. 50% will be during 2020, and 25% somewhere beyond that. So that is quite an interesting data point, and thank you for sharing with us.
Which I think quite corresponds with the topic of our presentation. If it is hyper-reality, well, it's a bit of both. So some are deploying it now, and some will deploy it later, and it's really happening, but it's not happening instantly and overnight. So having gone over all the theory, I want to really present two, I think, very interesting use cases of deployments on NFV-based networks, which we are engaged in these days. The first use case is NFV-based security solutions on a fixed network. Usually the networks are mobile, but in this case it's a fixed network. And it's actually a network based on VMware, where a customer is expanding his fixed networks on top of NFV-based VMware. And the solution that is provided is actually protecting customers and internet users from illicit websites. So all the customers who are connected to the internet via fixed network are getting this service from the operator, where the Allot solution, which is installed within the NFV-based network, is monitoring all the traffic of all the customers, and it is able to actually filter illicit websites which are deemed as blacklisted websites, and prevent customers from actually accessing such illicit websites. And in terms of actions that can be performed, this is really the operator's decision, where he can get reports, monitor which illicit websites are accessed, or he can take action, again with the Allot solution, and either drop a session to such an illicit website, or provide a warning, or redirect the customer to a captive portal, which will convey a message about illicit websites. And in a sense, this solution is actually deployed in the core network. You don't need to deploy it on the end routers or in the offices or anywhere. Everything is performed from one point in the core network. And this really, I would say, increases the business agility and the cost effectiveness, because all of the traffic is handled by the entity on the NFV network. Do we have questions, Michael, before I continue? Okay, so I thought so. So let's see a high-level diagram of how this solution is deployed, just to give a sense of what we are talking about. So hopefully everyone can see this. No, we are not in the right slide. We need the VMware-based one. Yep. Yes, this one. This is a spoiler. You already passed to the next slide. Okay, so this is a high-level diagram of the security services we are doing on VMware-based network, where on the left you have the fixed operators network with all the users connected to this network, and on the right you have the internet. All the part in the middle, the fixed network and the Allot service gateway, are deployed on a VMware-based NFV network. And what we are showing here is that all the traffic is traversing Allot service gateway and actually handled by our product. And what you see here is the same product that I showed before, where I showed the virtual chassis for NFV, which is the transition of our physical service gateway to a virtual service gateway. So here you have a fully virtualized service gateway deployed on a fixed NFV network. All the traffic is arriving to virtual machines which are operating as flow balancers, which can handle the traffic and direct them to the correct DPI element on the NFV network. The DPI element inspects the traffic and makes a decision whether this is an illicit website and whether this needs to be monitored, reported, blocked, directed to a captive portal. And also, as a benefit, the operator who is using our platform is getting monitoring and reports to get a sense of the activity that is being performed on the network.
And so, Ariel, is this an example of where the solution expands automatically if traffic increases and more sessions need to be monitored?
Okay, so this is a great question. Thank you, Michael. So what you see here are virtual machines, which are separate entities, but they are actually operating together as one virtual chassis. And what this means is that if there is more traffic, we can, by means of either manual spin up or via orchestrator, add more flow balancers to handle more traffic and more core controllers. And this way, the system itself can grow in size essentially and handle more traffic whenever the need occurs, and also do the opposite, which is actually reduce in size, which is unavailable completely when you're talking about a proprietary hardware-based solution. The system can actually reduce in size when there is less traffic. So this architecture allows allows for the system to, let's say, breathe and expand and reduce as needed. What I'm showing here, I referred to previously to Allot VNF Manager when I showed the Etsy architecture. And the VNF Manager is actually a management entity that has an API towards the cloud, towards VMware or towards OpenStack. In this case, it's towards VMware in this use case. And using the VNF Manager, you can, from one-stop solution, deploy the entire service and also spin up new services. What we see here is a screenshot of a service deployed on an NFV-based network, where in the middle there is the application itself, the different virtual machines and how they are connected. And on the left, you have a kind of a library of services or VNF descriptors, where each such service describes, each such descriptor describes a different service. So spinning up a new service is just about clicking the correct descriptor, and the VNF Manager automatically instantiates this service on the cloud. Okay, so this was our example for security services on a fixed network based on VMware infrastructure. The next use case I want to show you is a NFV-based security solution for mobile networks. And this time it's based on OpenStack infrastructure. Did we have a question, Michael? Okay, great. Can we mix VMware and OpenStack to provide one NFV platform to the company? Okay, that's an interesting question. Who did this question arrive from? Okay, great. So essentially, OpenStack and VMware are representing abstraction layers of how to deploy an NFV network. So you can deploy part of the solution on a VMware-based network and another part of the solution on an OpenStack-based network. For example, we have use cases where customers are deploying the user plane components on VMware and the management-based components on OpenStack. This is fine, as long as they have IP connectivity between them. There are also use cases of OpenStack being deployed over VMware, which adds a bit of complexity, but it's also possible. But yeah, I don't know if that answers your questions or not. But essentially, you can use two different infrastructures. So what is the use case of the security services on OpenStack for mobile-based networks? The use case here is actually providing, it's a two-ended solution. One side of the solution is actually securing enterprise customers, which are connected with IoT devices to the operator's network. And the Allot Service Gateway, in conjunction with another element, which I will present soon, is actually inspecting and managing all of the traffic that is arriving to IoT devices from the internet and preventing the IoT devices from being attacked by malicious software or botnets or any other command and control elements. So the business customer who is connecting his IoT-based devices over the NFV-based core network is getting protection from Allot system. The Allot system prevents IoT devices from being infected. On the other hand, the same Allot solution, which is deployed on the NFV-based network and protecting the IoT devices, is providing security for the operator's network itself. And this happens by protecting the network from IoT devices flooding the network with, let's say, unsolicited traffic. So in case IoT devices or smart devices or any SIM-based device is infected and is part of a bot network, it might try to flood the operator's network. And flooding the operator's network costs the operator a lot of money it can cost even tens of millions of dollars a year. And our solution, the same one that is protecting the IoT devices from incoming attacks, is protecting the operator's network from outgoing flooding of the network.
And this is especially important because often the service provider, the carrier network, is not the actual target. Some bad, malicious actors out on the network have infected a bunch of IoT devices and marshaling them into a botnet. And then there is another target, but to get to that target, they have to go through your network. And so you become an innocent bystander, and all of your other customers are impacted as well because you're the data pipe connecting everybody to the internet. And so this is a great example of a two-way defense system protecting both inbound problems from hitting your enterprise customers, but also protecting you should those IoT devices become infected through some other means, and then flooding you on their way to their inappropriate activities.
Yes, and all of this is done on an OpenStack-based network. So let's see how this looks like. Again, as a high-level diagram, we have as an infrastructure OpenStack, and on top of OpenStack, Allot is running a version of its service gateway, not the one you saw in the slide before, but another one. And another element, which is called the network secure, which is actually the one inspecting the traffic going back and forth from the IoT devices. On the left-hand side, we have the 4G or virtual evolved packet core network, where all the mobile devices are connecting. And on the right-hand side, we have the internet. So as in the previous example, all of the traffic arriving to the virtual EPC is being inspected and monitored by the Allot solution. On the downstream, all the traffic that is arriving from the internet is inspected by the service gateway and the network secure product. And any attack or any malicious activity that is attempting to contaminate IoT devices is removed. On the upstream direction, from the IoT devices to the internet, like Michael said before, in case any of the IoT devices is affected and is trying to overflood the operator's network with excess traffic, again, the Allot service gateway and network secure solution are inspecting this traffic and removing all of this excess traffic before it actually creates a problem for the operator's network, where additional bandwidth is consumed at the expense of legitimate traffic. So this is a high-level illustration of the solution.
Okay, so keying into that previous question, and given the two examples that Ariel has demonstrated here, we were curious if you know your carrier organization. Do you know whether they're planning or already deploying a VMware environment, an OpenStack environment, the AWS environment, or something else altogether? So we're just curious to see, this small sampling of what's happening in the industry. Okay, nice. So that's interesting. It's pretty close, 46% for VMware, 40% for OpenStack, nobody doing AWS, and 13.3 doing something else altogether.
Okay, which is actually a bit surprising, but...
Okay, well, that is interesting. Fun. And we've got one more question at this point. Again, it's getting a little bit more detailed, but do you know, and if you do, how your NFV network is being orchestrated? Is it through heap templates, through the ONAP methodology, or through VNFM, as Ariel described earlier, or some other orchestration technique. Okay, and what we have out there is half VNFM and half something else. Okay, so this is quite interesting as well.
Okay, thank you. So we are learning also. Great. Okay, I cannot speak about NFV without saying a few words about 5G and the NFV. So basically, the current networks we see are based on fixed networks on NFV and virtual EPC 4G networks on NFV infrastructure. But we do see the use case for 5G coming in and coming in strong. We have several customers and partners which are highly engaged in 5G. And just as a reminder to everyone, 5G is the next generation of network, which brings with it new features and functionalities that did not exist in 4G network. One of them is really an avalanche of traffic. There is much more traffic per user. If in a 4G network, we are talking about 40 to 80 kilobits per second on average per user. In 5G, we are talking about hundreds of times more than that. There are even theoretical use cases of, I believe, 100 megabits per handset in 5G. So this is something that is unheard of in previous networks. There is a huge growth in the number of connected devices, and this mainly comes from the proliferation of IoT and smart devices, which are all going to communicate and connect through the 5G network, and this needs to be handled somehow. And there are new use cases that are coming in, where the obvious ones are car-to-car communications, but there are also use cases for the medical industry and the use cases for military industry, where there are essential requirements for very short end-to-end delays, which are handled by a much faster 5G infrastructure, which allows very short delays and mobile edge computing and fog computing and all of the other things that are a part of 5G. So this is coming, and the infrastructure of 5G will eventually be a fully NFV-based network. So having a solution that is compliant with NFV is a great step to actually go with our partners on their journey towards 5G.
And I think one of the main concepts is that 5G is going to be very much a service-driven network, and that means that the virtualized ability to roll out more instances of a service or new services will tie very tightly into the NFV concepts that we're hearing about. And we've seen both from, as Ariel mentioned, customers, but also potential partners in the network equipment provider space who are looking for complementary pieces to help them realize full virtualization as well.
Yes, so I would like also to, let's say, go 30,000 feet up in the air and just say on a very high level on what is happening in the industry. So Michael asked you before about which platform is being used or will be used for NFV, whether it's OpenStack or VMware or AWS or other. So there is kind of a, let's say, a battle, clash of the clans between OpenStack and VMware. There are advantages and disadvantages to each, and each operator is making his own selection based on his business requirements. I'm happy to say that Allot, as a vendor for security services and DPI, is fully compliant with both OpenStack and VMware. So we are happy for both of them to continue marching and leading the way. There is also another issue that is maybe less talked about, but I will say it, is that NFV is a journey. Although it's more reality now than hype, it takes time to adopt NFV. It takes time to get the necessary skill set and make all of the investments and all of the testing that is necessary, and really bring the network to a situation that it's carrier grade and ready for production. And part of that journey is also determined for Allot as a company by the rate of adoption of NFV of our operators. So we have customers who are in more advanced stages, doing advanced POCs or initial production deployments, and we have customers that are in the middle of the journey, testing in labs, and we have customers that are mainly starting the journey and asking the questions and designing how all of this is going to look like. So there's no one solution for NFV. We are working with many customers, and we can really contribute from our experience and help you at any stage you are at to provide you the best fit solution for your NFV vision. Now, orchestration is part of NFV, where an orchestrator is the management element that is spinning up the end-to-end services from all of the vendors on one NFV environment. There are many orchestrators out there. There are orchestrators from HP and from Nokia and from Ericsson and from other companies. There are actually quite a few orchestrators. And it's not clear where that is going, which is going to be the dominant orchestrator and which is going to be de facto the standard. I do want to say a word about ONAP, which is led by AT&T. And this is actually a joint solution of AT&T eComp orchestrator and OpenO, which is another orchestrator. And together they are providing an ONAP orchestrator, which is quite comprehensive, which is able to run on top of VMware and OpenStack, and also model within all sorts of different ways and different descriptors which are out there in the market in order to spin up new services and do lifecycle management. So I think the industry is trying to find which is the best orchestrator to use. I haven't seen one that is the best one, I would say, but we are aware of this, and we are working with our customers to integrate to different orchestrators. So before we conclude and hand the conclusions to Michael, I would like to share maybe some wisdom we had in 2019, in all of this year, which we were very engaged in many NFV-based opportunities. And what we saw, and I would like to share with you, is that we didn't see any out-of-the-box NFV solution. We have our roadmap, we have our product portfolio for NFV, but once we started to design the blueprint of how NFV will be deployed at each customer, we saw that each customer has a different vision of how to do it. Some are using layer 2 over OpenStack, others are using layer 3, some are using Allot VNF Manager for orchestration, others are using their own orchestrators. Some are requiring that we provide just descriptors to provide lifecycle management. Others are requesting more tight integration to their orchestrators. Some are requesting standalone solutions where we are providing our solution within the network, and others are requiring a more tightly coupled solution which works in conjunction with the virtual EPC. So I'm not trying to confuse you. I'm just trying to say that really we are aware that every customer has his own vision, and we are trying to adapt so that each customer gets a solution that is best tailored for the way he sees NFV happening. Obviously, NFV, which has been around for quite a while and all the industry is engaged in it, is trying to become a standard, but it's not a standard per se like a 3GPP. But we do see common denominators, and we do see trends. But again, each implementation requires a deep dive, designing the application, providing blueprints, and providing a solution that is tailored fit for our customers. And looking forward, whenever you are going for an NFV-based network, as the part of the intention is to be future-proof and save costs and be ready for the new services and the new technology as they come in, we should start looking at 5G networks where all the solution is based on microservices and containers and orchestration. And like I said before, we already have some partners and customers that are engaged in 5G networks. And hopefully this will bring us to a higher level in terms of NFV in the future. So having said that, I will hand you over to Michael.
So if I can, just sort of summarize some of the conclusions in terms of the software-defined network and the NFV journey, it seems like you can't avoid the kind of, hype to reality path that we've seen in telecom. I remember when LTE kept not arriving, and the joke was that LTE actually stood for later than expected as opposed to long-term evolution. And then all of a sudden LTE was being the fastest deployed network technology in history. So we went through that cycle with LTE, and NFV is also, it's having its growing pains, but it's clearly coming. So the joke there was that NFV stands for not financially viable. But like LTE, it's becoming more and more real. And we've seen, and Ariel gave you a couple of real-life examples. There are many proof of concepts running out in the market. There are limited production cases which are coming online. And so we are making that transition. But having said that, and we saw it from some of the poll questions with yourselves today, timeframes need to be realistic because there are still issues out there. The lack of, agreed upon standardization, the different platforms that are still competing, and maybe there will always be multiple platforms, and so their interoperability issues need to be simplified, but it's happening. We need to all work together, vendors like ourselves, service providers and enterprises, as well as the cloud providers, and certainly the network equipment providers all need to work together to kind of speed things up. But the premise or the promise that this technology advancement will drive value and will bring savings and agility already is being demonstrated, but it still needs to be fully demonstrated. And the final takeaway is that I think of the case studies that Ariel discussed with you, which come from commercial activity that we're engaged in, show that it's real, it's already a reality, and it's becoming more and more real as time goes by. So we hope that that this webinar has helped you learn a little bit more about NFV, especially the fact that it's real and that it's happening. Again, on the screen, you've got the options to get in touch with us through the box on the upper right. There are some resources that we pointed you at, which are more functional descriptions of the kinds of services that we described in the context of NFV today, but that's more about the functionality that you get as opposed to the technology of deployment. You can, of course, ask some questions now. We have a few minutes that we can devote to Q&A, or you can send us questions offline and we'll do our best to get back to you. And finally, there should be a little survey window opening up at the bottom of your screen. And if it's there, please help us out with some basic feedback about this NFV. So thank you again. And as I said, there's the Q&A window. We'll stick around for a couple of minutes to see if anybody has any questions that they'd like to ask. And we've given you a number of avenues to learn some more about our solutions or to get in touch with us. We're happy to work with you moving forward, and hope this has been useful. Thank you very much.
Thank you, everyone. Okay, so we have a few questions coming in. Thank you for your questions. One of them was, are the slides available? So I started with the simplest question. And yes, they are, and you will get them. There is a question about, have we done any benchmarking with different NFVI? So we see that for carrier-grade operator networks, the predominant infrastructures are actually VMware and OpenStack. We have done some testing on AWS, mainly for enterprise and business-oriented customers. But as an operator that deploys and spins up a full carrier-grade network on NFV, we see that what is mainly being used is OpenStack and VMware, and these are the infrastructures that we are deploying upon and developing upon. And there's a question here, an interesting question. When is it necessary to update the OpenStack version? And does it depend on the services? So that's a very good question. OpenStack is actually a very alive and kicking community where a new version comes out every 6 months. So even if you upgraded your version after 1 year, you're already 2 versions behind. So a lot of the new modules that are added to new OpenStack versions are not necessarily applicable to your use cases, so you don't necessarily have to upgrade. But I did hear in the last OpenStack Summit, not the last one that was a month ago, but in the one before, 6 months ago, that there are tools in OpenStack to directly upgrade a very old version to the newest one, skipping all the versions in the middle. So if you reach a situation where a new OpenStack version is addressing features and capabilities that you require that did not exist in your current OpenStack version, you do have the ability to directly skip to that version. An example for that would be high availability that is more relevant to the latest OpenStack versions and does not exist in the previous ones. So hopefully that answers your question. Let's see if there are any others. Okay, this is a good one. There was a question about, is there any broad generalization about savings that should be expected by deploying NFV solutions for DPI versus dedicated appliances? So in terms of presenting savings, this is something that needs to be related to the business case. In general, NFV saves you the money of the proprietary hardware, which is a very substantial and expensive component when we're talking about DPI. The hardware is based on proprietary hardware, which is very expensive, and when we move to NFV, our software runs on an IBM, an HP, and any standard server, providing we get the appropriate resources from this server, and this by itself is already a huge saving. We can probably show business models that show how transitioning to NFV saves you money, but this is really as a reference. Every customer will have his own business model, and within that, we can see how much in the long term can be saved by transitioning to NFV. Another thing which is not about a direct comparison between proprietary and NFV is that really the industry is moving to NFV. And like I said, 5G networks, which are coming next, are entirely based on NFV solutions, on NFV network. So there is no room anymore for proprietary-based hardware. So that also gives a sense of the importance and the urgency to be NFV compliant.
Okay. And there's also the perhaps harder to evaluate, but there's the OpEx side of NFV savings as well. So besides having, more efficient utilization of lower cost hardware, because obviously somewhere there's going to still be hardware that's running the software, but it's less expensive. But the efforts to deploy and to maintain and to troubleshoot and so on should also be significantly lower. But I think that'll take time. It's more of an empirical question to see how that actually plays out.
Okay, I think we covered the questions.
So thank you again all for joining us, and please feel free to get in touch. We'll leave the session open for a few more minutes, and you can utilize those contact us links as well as the resource downloads. So thanks again. Bye-bye.